Good evening, everyone. Thank you for joining this urgent meeting on such short notice. We have a serious issue that needs to be addressed immediately. So we can see in the chart, our financial is not really good. We are in highly competitive snack food industry, and our current profit margins are not meeting expectation. We need to optimize our profits if we want to sustain and grow our business. So the main issue is we have Banans that produce banana chips in three different flavors: original, spicy, and balado. However, our resources are limited and have specific production needs for each flavor. Let me break it down for you. Next, okay, so we have less than 20,100 kilograms of raw bananas, 49,100 kilograms of cooking oil, 45,000 kilograms of milk powder, 18,750 kilograms of white sugar, 6,000 kilograms of salt, and 12 kilograms of flavoring powder. We need the original flavor, which is salty, has a net weight of 120 grams. The spicy flavor is 130 grams, and the butter flavor is 18 grams. So I will show you this slide about our financial details. So in here, we have our capital is 270 million rupiah, and the operational costs are 4,000 rupiah for large size, 5,000 rupiah for medium size, and 600 rupiah for small size. We have production limits of 35,000 packages for the original flavor, 20,000 for the spicy flavor, and 16,500 for the pellet flavor. We need to sell the large size for 12 rupiah, the medium size for 10,000 rupiah, and the small size for 1,000 rupiah, making profits of 8,000 rupiah for the large. And then for the medium, we have the profit for 5,000 rupiah, and the small size, we have profit of 400 rupiah per package. So we need to move forward from here. To overcome these challenges and maximize our profits, we need to use the SIMPLEX method of linear programming. This will help us determine the optimal production of quantities for each flavor, ensuring that we utilize our resources effectively and maximize our financial returns. And we need to implement the strategy immediately. We will start this calculation right after this meeting. It's crucial that we act fast to turn our situations around. This is not just about making banana chips. It's about securing our future in these competitive markets. So maybe that's all. Thank you for your attention. Let's work together and make this happen. Any questions before we conclude? Okay, maybe there's none. Great. I expect to see progress in the next few days. Thank you, everyone. Meeting adjourned.
Okay, thank you, ma'am.
The next day.
To find Banans profit maximum, using POM QM, we must enter all the equation data into the main table. And here, I have entered all the existing equation data from raw materials, that is, raw banana, oils, milk powder, and etc. Until the limit of its flavor. And to find the result, we can choose the solution in here. So the program will solve the solution from the linear equation. And we can see the linear programming result, the ranking, the solution list, the iteration, or the dual. And for the linear programming result, we get that for x1 is for original flavor, x2 is for spicy flavor, and x3 is for balado flavor. And we get the maximum production for the x1 or the original flavor is 35,000. For spicy is 20,000, and for balado flavor is 16,500. So we get the maximum profit, the Banans, if can sell all the maximum production is 386,600,000 rupiah.
Okay, so hi guys, here I will show you how to solve that problem with the SIMPLEX method. From the given information of the problem, we know that X is the original flavor, Y is the spicy, and Z is the balado flavor, right? And from the information also, we have know that the constraint of the linear problem is here, like this, and then we have the objective function is equal to Z equal 8,000x plus 5,000y plus 400z, right? And then we will show you how we maximize Z equal to 8,000x plus 5,000y plus 400z with the constraint function here. So table in here. So we write that from here. until here and so like this. And don't forget to change the S9 in here into the Y variable, and the CB is the value of Y on the objective function. Here is 5,000. So this is 5,000. Okay, next will be explained by Kak Laili. Okay, bye-bye.
Hello guys, I'm going to continue the manual calculation of the simplex method. So we have the result of the iteration 2, and we can add the result into the new simplex table in here. So for the next step, we can calculate the ZJ in here. You multiply the CP with all the variable in here, also the quantity. So we get the new simplex table in here. Don't forget to change the VGP or variable dalam basis in here. Okay. Yeah. Variable dalam basis in here by the variable z, and we change the CP in here by the coefficient of z, that is 400. So we get the variable dalam basis or VGP in here is x, y, and z. And next we calculate ZJ in here. For the first, we calculate the quantity. We multiply CP with the quantity in here. CP 0 times it times here, 0 times it, 0 times it, and etc. until 400 times 16,500. So we get the result is in here. That is 386,600,000. And we do the same way for all of the variable until S9, S10, I mean. So we get the value of ZJ in here. For the variable X is 8,000, Y is 5,000, Z is 400, S8 is 8,000, S9 is 5,000, and S10 is 400, and the rest is 0. Next, we calculate the ZJ, mean CG in here. We have the value of ZJ in here, and we have the value of CJ in here. So for the first variable is, for variable X, we have 8,000 minus 8,000 is equal to 0. For the variable Y is 5,000 minus 5,000 is equal to 0 also, and etc. until we have the result like this. So we can look at the result for ZJ min CJ in here. All of the value of ZJ min CJ in here is greater than 0. So we can conclude that the table is optimum. Hence, the optimal solution from this table is arrived with the value of the variable as follows. So we have the variable X in here. We have the value 35,000. For the variable Y, we have the value 20,000. For the variable Z, we have the value 16,500, and etc. until S1, S2, S3, S4, S5, S6, and S7. And we get the Z maximum in here. We get 386,600,000. We can also check the value of Z using the objective function. So we have Z is equal to 8,000x plus 5,000y plus 400z. So we can change the variable x, y, z, x, y, z in here, x, y, z in here by the value in here. So we have 8,000 times 35,000 plus 5,000 times 20,000 plus 400 times 16,500. And then we have the result is 386,600,000. So we have the value of Z based on the calculation of objective function is equal with Z maximum that we get it from the table in here. So we can conclude that the optimal value is true.
The next day.
Good evening, team. I wanna know the report about our sales. Can any of you present it?
I will present it, Miss.
All right.
Okay, so for our production, for original flavor, we have maximum production 35,000 pieces with profit 280,000. I'm sorry, 280 million. And for spicy flavor, we have maximum production 2,000 to 20,000. I'm sorry, with the profit 100 million. And for the last balado flavor, we have maximum production 16,500 pieces with profit 6,600,000. So we have maximum production for all flavor is 71,500 pieces, and maximum profit for all flavor is 386,600,000. It's all from me. Thank you.
All right, thank you. So I'm thrilled to see that our sales have skyrocketed since we implemented this new strategy. We have optimized our production and the results are beyond expectation. That's such a great news. And because this profit is better than ever, and also the feedback from us customer has been overwhelmingly positive, I want to thank each of you for your dedication and effort. To show my appreciation, I have decided to reward the entire team with a bonus. You've earned it. Okay, let's keep this momentum going and
Thank
continue.
you,
to innovate. Yeah, you're welcome. And thank you, everyone. And maybe that's all for our meeting today.
Probably not strong. We're not going today, we're going.